Welcome to the Unit 1 review. We're going to start by reading the instructions. For number 1 through 6, find the domain, which we know are all our x values, and the range, which are all our y values, for each relation. Give an interval notation, and we know that interval notation we use parentheses and brackets. Okay, remember parentheses are going to be open circles and brackets are going to be our closed circles. And answer the related questions. Okay, now for domain, we know that we're going from left to right. And that's from negative infinity to positive infinity. And then we know for range, we're going from down to up, which is going to be also from negative infinity to positive infinity. Okay, so now we need to look at each of these and then figure out what the domain and range are for each of these. So let's start with the first one. Now I'm going to identify a few things on this graph before I even start talking about the domain and range. All right, I know that this is a closed circle. That's where my starting point is, and I know that because this is reaching the edge of the graph that there should be an arrow there symbolizing that it's going on forever. So let's talk about the domain. As I start from the left-hand side, I'm looking for that starting point of the graph, and I see that that starting point is, okay, so this point right here is -4, 0. And again, as we move from the left, we see that the starting point, okay, for the domain, because we're looking at the x value, is at -4. And it includes that number, so I'm going to use a bracket, comma, and then we wanted to see if there's any endpoints. As we move to the right, there's no endpoint, and we know that it goes forever, which means that it's going to positive infinity, and we would know that we're going to use a parenthesis with positive infinity. All right, let's take a look at the domain. I'm sorry, the range. So the range, we're going to start down here, and we're going to move our way up. Notice, again, that we have this starting point, but now we care about the y value. The y value there is going to be 0, and again, a bracket, because we're going to include that. And then we want to keep moving up, and we see that it's going to go up to positive infinity, and we're going to use a parenthesis with positive infinity. So there's our domain range. If we do a vertical line test here, okay, we could see that yes, this is a function. Now the next question is asking us f of -4. Okay, well that means when x is -4, what's my output? So let's find on our graph where x is -4. Oh, that's our starting point. We know when x is -4, our output is 0. All right, now let's say the next one, it says f of x equals 3. Well, that's saying that y is 3. So let's look at the graph and find what y is 3. 1, 2, 3. Here is where y is 3. Well, my x value here, this would be 0, 3, which means my x value, and look, it even tells you x equals 0. All right, let's move on to the next question. Again, we have domain and range. I'm going to mark up my graph a little bit first before I even get started. All right, I know this reaches the edge of the graph, so these are going to have arrows at the end of them. So let's start moving from left to right again. We're going to start with domain. We see that this is going to go on forever, and it's going to keep moving towards negative infinity for the domain. And then if I keep going all the way across, I see that it's going to keep moving to the right, which means my domain is negative infinity to positive infinity. And we're going to do the same thing for our range, except we're going to go down to up, so down. See that this arrow here, this graph is going to continue down, which means that I start at negative infinity for my range, and then I'm going to go up, and I see this arrow here is going to keep going up, which means that it's going to positive infinity. Again, if we do a vertical line test, I can see that this is also a function. Okay, same thing here. F of negative 3, so it's telling me x is negative 3. All right, my input is negative 3. What's my output? So I'm going to find x is negative 3. 1, 2, 3. It wants to know what my output is. Okay, so my output, because this is negative 3 comma 1, it's going to be 1. And then here it says that f of x or y equals negative 2. So I'm going to find on my graph where y is negative 2. It wants to know my x value. Well, I know that this is 0 comma negative 2, which means my x value is 0. All right, let's look at the next one here. All right, so let's look at the domain. I'm starting over from the left, and I notice that my very first value, okay, for x is about right here, which is at negative 4. So this graph does not start until negative 4. Notice there's no arrows pointing in either direction. So I'm starting here at negative 4, and it does include negative 4, so I'm going to use a bracket. And I'm going to keep going, keep going, keep going. Okay, it stops here, and I'm looking for that x value. And the x value there is 1. And I see I have one open and one closed circle. Okay, so that closed circle means that I'm going to use a bracket. All right, let's take a look at the range now. Okay, starting down, I see that my first y value for the range is going to be negative 2. Notice that this is an open circle. Well, because it's an open circle, I'm going to use a parenthesis, and then I'm going to keep going up, and then I'm going to look here, because this is where it stops. Remember, we're talking about range, so I want my y value, which is 4, and this is a closed circle, which means I'm going to use a bracket. If we did a vertical line test here, and I'm not drawing on the paper because I don't want it to get too messy, I can see this is not a function, because, for example, if I look here at this x value, which is negative 2, I have an output of y here and an output of y here, which means this is not a function. All right, let's take a look at the next one. All right, so I'm looking here, and I notice there's an endpoint. So before I even get started, I'm going to go ahead and label that endpoint. So that's going to be 6, 2. All right, let's talk about the domain. All right, I'm going from the left. Notice that this arrow here means that I'm going down, but I'm also slowly moving to the left, which means that this graph starts at negative infinity for the domain. But if we keep going, it stops right here. Well, the x value where it stops is 6. It's a closed circle, so we're going to use a bracket. And then doing the range, we're starting down here. This arrow is pointing down, so we know that it's from negative infinity. Okay, and then we stop right here. And remember, we were carried about our y value, and we know our y value there is 2. Closed circle, again, we're going to use a bracket. Again, vertical line test would say, yes, this is a function. All right. We have f of 4. So it's asking when x is 4, what's my output or what's my y value? So let's go find where x is 4. All right. What's my y value, which is right here? So that's going to be 4 comma 1. So where x is 4, y is 1, or my output is 1. All right, let's take a look at f of x equals 2. So this is telling you that where y is 2, what's my value of x? So y is 2. So 1, 2. What's my value of x? Well, look right here. We already wrote that. Where y is 2, x equals 6. All right, next one. All right, we have some asymptotes here. So before you even write anything about the domain and range, I want you to write where these asymptotes are. So this asymptote right here is at x equals 2. This one here is y equals 3. All right, so let's do the domain. Mark up my graph here. I know this is going, these have arrows here. So notice this arrow is pointing toward negative infinity, which means this graph is going to keep going, which means my start point is negative infinity. All right, and if I go along here, I see that it's going to stop here. Well, this value here is 2, so it is that asymptote. It's getting really, really close to that, but it's never going to actually reach 2. So we're going to say it goes to 2 with a parenthesis because it does not include 2. But remember, we've got to talk about this other piece of the graph here. So we're going to say union. Now we're going to describe this piece of the graph. Again, it's getting really, really close to that asymptote, but never touching it. So it's going to go to 2, from 2, and then notice that it's going to go on to infinity. Now let's talk about the range. For the range, we're starting down here, negative infinity. All right, and then we have an asymptote here where y is 3. Okay, so there's our first part of the graph. But then we've got to describe this other piece of the graph. So we're going to say union with. It's going to pick up on the other side of the asymptote at 3 and go on to positive infinity. Do a vertical line test here. And yes, that is a function. And then again, f of 1. So x is 1. It wants to know what my output is. So let's go find x is 1. And we see right here, about right here, x is 1, which means my output, my y value right there is 2. And then let's take a look at this. F of x, so they're saying that the y value equals 4. So the y value is 4. And it wants to know what my x value is. So it looks about right there. And I see that my x value right there is going to be 3. All right, let's take a look at the next one. All right, notice that we have some pretty distinct endpoints here. I've got an endpoint here at -6, -4. An endpoint on the other side here at 8, -3. All right, so let's see. I'm going to start on the left. We do have a starting point with that endpoint, so we know that the domain is going to start at, that's -7, isn't it? Sorry about that. It should be -7. Right there, that's -7. So my domain is going to start at -7, and that is an endpoint, so I'm going to use a bracket. And then I'm moving along here for my domain. Notice that it stops right here. Actually, there's a break here. It stops right there. So that value there is 2, 2. So it stops at 2. And notice an open circle, so I'm going to use a parenthesis. But I still need to talk about this other piece of the graph, so I'm going to say with union. And then it picks up right here, which is going to be at 3, -3. But remember, we're talking about domain, so I want my x value. Closed circle, so I'm going to use a bracket. So from 3, 2, and then it stops again right here. And we said my x value here is going to be 8. To open circle, so I'm going to use a parenthesis. So it's kind of good to label all those points first, because then it's easier to do your domain and range. All right, let's do the range. So we're starting down here. My first value here, okay, is going to be at -4. And notice this is a closed circle here. So -4 is my first value. So I'm going to use a bracket, -4. And I'm going to keep going. And then my last piece of the graph there ends at 4, and we're also going to use a bracket for that as well. Okay, if we do a vertical line test, this is a function. All right, and then let's take a look here. We said f of -4, so that's saying where x equals -4. So x is -4. What is my value of y? So where x is -4, my value for y is 4. And then it says f of x, which we know means where y is -4. So where y is -4, what's our value of x, which we actually already talked about that. So where y is -4, x is -7. All right, let's go down to the bottom. All right, this should be a little easier now because we've kind of already talked about this type of notation. So right here, I say, I've got a new graph here, but I'm saying that f of -5. Well, f of -5, that means where is x? -5. What's my output? So let's find where x is -5. Here, okay, where is my y value? Well, right here, x is -5 and y is 3. So where x is -5, my output is 3. And this one says f of x equals 3. Notice the difference between these two notations. This is saying y is 3. What is x equal? So let's find where y is 3. 1, 2, 3. Well, where y is 3, all right, I don't have a ruler handy, so I'm actually going to draw in that line where y is 3 so that I can make sure that I've got everything covered. So where y is 3 would be anywhere on this line. Well, notice that I have more than one answer. There's a little hint here that says there are 2 necessary answers for B. So I have one here, which we've already talked about. So where y is 3, x equals -5. But then look, there's actually a point here as well. This also represents where y is 3. And the x value is, I would say, about 9.75. So we also have x equaling 9.75. So there's 2 answers here. So be careful with these type of problems to make sure that you have all of the solutions. All right, let's look at the next one. We have f of 0, which means that x is 0. I want to know where x is 0. Okay, and x is 0, I know, on the y-axis. So this right here is where x is 0. And that value would be about -3.1. So when x is 0, y is about -3.1. And then again, does it represent a function? If we did a vertical line test here, all the way, we would say yes, that it does represent a function. All right, moving on to page 2. Okay. Number 8, given the following graph, an incorrect domain and range, find and correct the errors. So let's take a look at my graph here. All right, so let's see. See a pretty absolute value function. I'll put some arrows on there. I'm going to actually label my vertex too because I'm pretty sure I'm going to need that. So 1, 2, 3, so that's -3, -4. Okay, so let's take a look here. The first thing is that we have a domain of -5, -1. Well, -5, -1, that doesn't include all of my domain, okay? Because I know that if I go from left to right, that my domain should be negative infinity to positive infinity. Let's look at our range. Okay, so our range, -4. Now, I don't like this part. I like the -4 part, but I need a bracket there because it's starting at -4 at my vertex, and then I'm going on to positive infinity. So I like that it's positive infinity, but notice that this has a bracket. We always use parentheses with positive infinity. So there are errors, and we fixed them. All right, let's take a look at the next one. It says circle each of the relations that have a domain of negative infinity to 4, and we're using a bracket, so we're including 4. There will be more than one correct answer. So you want to get used to these problems because they like to ask them on the SOL and give you more than one correct answer. All right, remember domain is X, so I went through and I marked where 4 is for a value of X on each of these graphs. So I just marked where 4 was on each of these graphs. So basically what I'm looking for is I'm looking for a graph that includes 4 and goes to negative infinity. Okay, so let's take a look at the first one. So, okay, it looks like it starts at 4 and it definitely goes to a negative infinity because I'm just talking about the domain. But notice this is an open circle, so it doesn't include 4, which means I can't use this one. All right, let's look at the next one. All right, I'm starting at 4. I've got a closed circle, so I included 4. And I want to make sure that that graph only exists towards the left because it says negative infinity. It's going from negative infinity to 4, and it does. So this is definitely one of my answers. All right, let's start here. So a linear function, we know it goes forever in both directions. So if I started over on the left for domain because I want to start at negative infinity, I know that that graph will go towards negative infinity. But does it stop at 4? No, it keeps going. So this cannot be 1. All right, looking at the next one, I'm starting over here. We're in negative infinity. Going, going, going. Okay, definitely that graph exists over here, negative infinity. And then stop. It stops at 4. And it includes 4. So yes, this one works as well. All right, let's take a look at the next one. So I'm starting over here at the left. I want that graph to exist over here at negative infinity, which it does. I'm good, I'm good, I'm good. 4 is way out here, but notice that this graph is going to keep going and going and going. It does not stop at 4, which means this cannot be an answer. We want it to stop and include 4. All right, let's take a look at the next one. We're starting over here at the left, negative infinity, go, go, go. All right, I know that this is definitely going on. And then stop. It stops at 4. So far, so good. But remember that this is an asymptote, which means it gets really, really, really close to 4, but it does not include 4, which means this is not an answer. Okay, let's look at the next one. There's an arrow here. So over here, at negative infinity, going, going. Yep, it includes negative infinity. And up, we stop at 4. And this has an endpoint. And it does include 4. So this one's an answer. All right, let's take a look at our last one. So over here, we're starting on the left, negative infinity. Remember, this arrow means that it's going to keep going. It's definitely going down, but remember, it's also going to the left. All right, and we've got 4 over here. But if we notice, this is going down, and it's going to slowly go down and to the right, which means it's going to go past 4. And it says, according to this notation, that it's stopping at 4, which means that this is not an answer as well. So our answers are this graph, and this graph. So you have 3 answers for this one. All right, let's take a look at the next one. It said, read the given sentence, then write the corresponding phrase in interval notation. All numbers from but not including -8 up to and including 13. So the first thing I'm going to do is I'm going to write some stuff down because reading all these words, this is too much. All numbers from not including. Well, what do we know not including means? If we're talking about interval notation. Not including means I need a parenthesis. -8. So I'm just going to write -8 down because I don't want to have to read the sentence again. Up to and including, well, I know including has a bracket, 13. So I'm going to write 13 down. Hey, look, I already have the answer. Parenthesis, -8, comma 13, bracket. So all you're doing is taking those words and translating it into the numbers and symbols. If you do it that way and do it every little piece at a time, this question is pretty easy. All right, last one for this video, number 11. It says, for each of the following graphs, name the function family and give the equations of the parent graph. Okay, let's look at number A. A is very distinctly a V shape, and we know V shape is absolute value. And we know absolute value equation is f of x equals the absolute value of x. All right, let's look at the next one. Oh, this one's rational function, because I know that I have this asymptote that exists here. I've got this guy here. I've got this guy here. Okay, so I've got vertical and horizontal asymptote, so I know that this is a rational function. And I know my parent equation is f of x equals 1 over x. Remember, rational means ratio, which we can remember as a fraction. So 1 over x. Let's take a look at the next one. This is the one everybody better get right. This is a line, so it's a linear function. And the parent equation is f of x equals x. Okay, and then the last one, right, this has, looks like a W, has 3 turns. This is a quartic. And quartic, okay, the equation is f of x equals x to the 4th. That is it for this video.